Close your eyes for a moment, and let me take you on an extraordinary journey through time. Transport yourself back 1,000 years, to the summer of 1054. Chinese astronomers stand in awe, their eyes fixed upon an unprecedented sight. There, in the daylight sky, a new star has appeared, one so brilliant it outshines every celestial body except the sun and moon. What these ancient astronomers witnessed was not the birth of a star, but rather its spectacular death. They were unknowingly documenting one of the most significant astronomical events in recorded history, the explosive creation of what we now call the Crab Nebula. For nearly 2 years, this cosmic firework remained visible in broad daylight. Even after the sun set, it dominated the night sky, bright enough to cast shadows on the ground. This celestial visitor was so extraordinary that it was recorded in rock paintings by Native Americans and documented by astronomers across Asia. Today, when we point our modern telescopes toward this same spot in the constellation Taurus, we see something equally magnificent, a sprawling cloud of gas and dust, still expanding from that ancient explosion. At its heart pulses something even more remarkable, a rapidly spinning neutron star, the incredibly dense corpse of that once mighty star. The Crab Nebula stands as a testament to the raw power and beauty of our universe. It reminds us that even in death, stars can create something of extraordinary beauty and scientific importance. This cosmic masterpiece continues to teach us about stellar evolution, physics under extreme conditions, and the very fabric of space and time. Before we dive deeper into this fascinating cosmic story, I'd love to have you join our community of space enthusiasts. If you're already captivated by this tale of celestial transformation, hit that like button. It helps more people discover these cosmic wonders. And if you want to embark on more journeys through the universe with us, subscribe to Exploring the Universe and activate that notification bell. Together, we'll unravel the mysteries of the cosmos, one celestial object at a time. Now, let's explore what makes the Crab Nebula one of the most studied objects in our night sky, and discover why this cosmic relic continues to fascinate astronomers nearly a millennium after its creation. Today, we embark on an extraordinary journey into one of the universe's most dramatic stories, the explosive saga of the Crab Nebula. This cosmic tale has everything: a stellar death, an incredible transformation, and a legacy that continues to shape our understanding of the universe. Picture this celestial theater, located approximately 6,500 light-years from Earth in the constellation Taurus. Here lies a cloud of glowing gas and dust spanning roughly 10 light-years across. But this isn't just any nebula. This is the aftermath of one of the most energetic events ever witnessed by human eyes, a supernova explosion that occurred nearly a millennium ago. What makes this cosmic remnant truly special is that it's one of the very few celestial objects where we know exactly when and how it was born. This rare privilege allows us to study the complete evolution of a supernova remnant, from its violent birth to its current state, giving us an unprecedented window into the life cycle of massive stars. As we delve deeper into this cosmic mystery, we'll uncover how a star, many times more massive than our Sun, reached its dramatic finale. We'll witness how this celestial giant's death throes created not just the beautiful nebula we see today, but also forged many of the heavy elements essential for life itself. The Crab Nebula serves as a cosmic laboratory, teaching us about extreme physics that we could never replicate on Earth. From the incredible densities of neutron stars to the acceleration of particles to nearly the speed of light, this celestial wonder continues to push the boundaries of our scientific understanding. But perhaps most importantly, the story of the Crab Nebula reminds us of our own connection to the cosmos. The very atoms that make up our bodies were once forged in stellar explosions just like this one. When we study the Crab Nebula, we're not just observing a distant object, we're learning about our own cosmic origins. Join me as we unravel this celestial mystery, exploring how the death of one star created one of the most studied and photographed objects in our night sky, and discover what it tells us about the grand cycle of stellar life and death in our universe. This explosive tale of cosmic transformation is just beginning. Let's travel back in time to understand how humanity first discovered and began to unravel the mysteries of this remarkable celestial object. The historical journey of the Crab Nebula reads like a detective story, spanning nearly a millennium of human observation. Let's walk through this fascinating timeline that showcases humanity's growing understanding of this cosmic wonder. Our story begins in the year 1054 AD. Chinese imperial astronomers, meticulous in their observations, recorded the appearance of what they called a guest star in their sky charts. According to their detailed records, this new star appeared in the constellation Taurus, blazing so brilliantly that it remained visible for 23 days, even in broad daylight. Japanese, Arabic, and Native American observers also documented this extraordinary celestial event. For centuries afterward, this cosmic spectacle seemed to vanish from human records. The bright point of light gradually faded, and the world entered the dark ages of astronomy. But the story was far from over. Fast forward to 1731, when British astronomer John Bevis made a crucial discovery. Through his telescope, he observed a faint, fuzzy patch of light in exactly the same region where the ancient astronomers had recorded their guest star. This was the first modern sighting of what we now know as the Crab Nebula, though at the time, its true nature remained a mystery. 27 years later, in 1758, French astronomer Charles Messier was scanning the skies for comets when he stumbled upon this same fuzzy object. It became the first entry in his famous catalog of non-cometary fuzzy objects, designated as Messier 1 or M1. This catalog would later become an essential reference for astronomers worldwide. The nebula's distinctive name emerged in 1844, thanks to Irish astronomer William Parsons, the third Earl of Ross. Using what was then the world's largest telescope, the 72-inch Leviathan of Parsonstown, he produced detailed drawings of the nebula. In these sketches, he noted that its strange filamentary structure resembled the legs of a crab, and the name Crab Nebula was born. But perhaps the most revolutionary discovery came in 1968, when astronomers Jocelyn Bell Burnell and Anthony Hewish detected something remarkable at the nebula's heart. They found a rapidly spinning neutron star, a pulsar, flashing like a cosmic lighthouse 30 times per second. This discovery not only confirmed theories about supernova remnants, but also opened an entirely new chapter in our understanding of stellar evolution. Modern observations have continued to reveal new secrets about the Crab Nebula. We now know it's expanding at an astonishing rate of about 1,500 kilometers per second. The glowing filaments we see are actually the original star's outer layers, still hurtling through space from that ancient explosion. Meanwhile, the central pulsar acts like a cosmic generator, powering the nebula's ethereal glow through its intense magnetic field. Each of these historical milestones represents a leap in our understanding, transforming the Crab Nebula from a mysterious guest star into one of the most studied objects in our galaxy. It stands as a testament to humanity's enduring curiosity about the cosmos and our growing ability to unravel its mysteries. Now that we understand how humanity discovered and documented this celestial wonder, let's explore the fascinating physics that makes the Crab Nebula such a unique laboratory for astronomical research. To truly understand the Crab Nebula, we must first grasp one of the most spectacular events in our universe, a supernova. Imagine nature's most powerful explosion, an event so magnificent it can briefly outshine an entire galaxy of hundreds of billions of stars. A supernova is the grand finale in the life of a massive star. But what exactly triggers this cosmic fireworks display? Let's break down this fascinating process. Picture a star 8 to 20 times more massive than our Sun throughout its life. This celestial giant maintains a delicate balance between two opposing forces. In its core, nuclear fusion creates an outward pressure that prevents the star from collapsing under its own enormous gravity. This cosmic ballet continues for millions of years as the star fuses increasingly heavier elements, starting with hydrogen, then helium, carbon, and so on. But this process can't continue indefinitely. Eventually, the star develops what astronomers call an iron heart. Iron is unique because fusing it consumes rather than releases energy. This marks the beginning of the end. When enough iron accumulates in the core, nuclear fusion can no longer generate the pressure needed to counteract gravity. What happens next occurs in a matter of seconds, but it's one of the most violent events in the universe. The star's core, about the size of Earth, suddenly collapses. This collapse is so extreme that in less than a second, the core shrinks to a sphere only about 10 miles across. If you could somehow watch this process, you'd see the core's outer layers falling inward at about a quarter of the speed of light. This catastrophic collapse creates a rebounding shock wave of unimaginable power. The shock wave rips through the star's outer layers, heating them to temperatures of billions of degrees. These outer layers are then violently ejected into space at speeds reaching 10% of the speed of light. The energy released in this process is staggering. In just a few weeks, A supernova can release more energy than our sun will emit over its entire 10 billion year lifetime. During this explosive process, the intense heat and pressure create conditions perfect for nucleosynthesis, the formation of heavy elements. Gold, silver, uranium, and many other elements heavier than iron are forged in these cosmic crucibles. In a very real sense, the gold in your jewelry was likely created in an explosion similar to the one that formed the Crab Nebula. What remains after this cosmic catastrophe depends on the original star's mass. In the case of the Crab Nebula, the explosion left behind a rapidly spinning neutron star, a pulsar, surrounded by an expanding shell of hot gas and debris. This debris, still visible today, continues to race outward, carrying with it the elements created in the explosion, seeding the cosmos with the building blocks for future stars, planets, and potentially life itself. The supernova that created the Crab Nebula gives us a unique opportunity to study these incredible events. Because we know exactly when it occurred, we can track how the ejected material has evolved over time, providing crucial insights into the physics of stellar explosions and the enrichment of our galaxy with heavy elements. The Crab Nebula is far more than just a pretty cosmic cloud. It's a complex structure with distinct components, each telling its own part of this celestial story. Let's dissect this cosmic wonder and explore its fascinating anatomy. First, let's examine the nebula's most visible feature, its intricate network of filaments. These ghostly tendrils are actually the shredded remains of the original star, violently ejected during the supernova explosion. These filaments contain mostly hydrogen and helium, but they're also enriched with heavier elements like carbon, oxygen, and iron, all forged in the star's final moments. These filaments continue their cosmic dance, expanding outward at an astonishing rate of about 1,500 kilometers per second. They form an elaborate tapestry of gas and dust, glowing in various colors due to different chemical elements and temperatures. The distinctive reddish hue comes primarily from hydrogen, while the bluish regions indicate the presence of oxygen. But what truly makes the Crab Nebula unique is its second component, the synchrotron radiation. This is where the nebula reveals its more exotic nature. Imagine countless electrons, accelerated to nearly the speed of light, spiraling through powerful magnetic fields. As these particles dance along magnetic field lines, they emit radiation across the entire electromagnetic spectrum, from radio waves to visible light, and even up to powerful X-rays and gamma rays. This synchrotron emission gives the Crab Nebula its characteristic blue-white glow in high-energy observations. It's like a cosmic particle accelerator, far more powerful than anything we could build on Earth. The energy involved is so intense that the entire nebula glows with the power of about 100,000 suns. At the heart of this celestial spectacle lies the third, and perhaps most extraordinary component, the central pulsar. This is the star's incredibly dense corpse, a neutron star rotating about 30 times every second. Despite being only about 20 kilometers in diameter, this cosmic lighthouse contains more mass than our sun, compressed into a sphere roughly the size of a city. The pulsar acts as the nebula's power plant. As it spins, its incredibly strong magnetic field accelerates particles to near-light speeds, feeding energy into the surrounding nebula. This process creates a unique phenomenon called a pulsar wind nebula, where the high-energy particles from the pulsar interact with the slower-moving supernova debris. Think of it as a cosmic double act. The expanding shell of filaments tells us about the supernova explosion itself, while the glowing synchrotron radiation and pulsar reveal the ongoing processes energizing the nebula from within. This combination makes the Crab Nebula an invaluable laboratory for studying extreme physics. The interaction between these three components creates a dynamic system that continues to evolve. The pulsar's energy output gradually changes the nebula's appearance, while the expanding filaments carry the story of stellar death into the surrounding space. Modern telescopes can observe each of these components separately, giving us a comprehensive view of this cosmic wonder. At the very heart of the Crab Nebula lies one of the most extraordinary objects in our known universe, a pulsar that stands as a testament to the extreme physics that govern our cosmos. This cosmic lighthouse, spinning at an almost incomprehensible rate of 30 times every second, represents nature operating at its absolute limits. Let's grasp just how remarkable this object is. Imagine taking an object with more mass than our sun and compressing it into a sphere only about 20 kilometers across. The density is so extreme that a teaspoon of this neutron star material would weigh as much as all the ships in Earth's oceans combined. This incredible compression creates magnetic fields trillions of times stronger than Earth's. As this cosmic lighthouse spins, it emits beams of radiation from its magnetic poles, much like a celestial searchlight sweeping through space. These beams contain radiation across the entire electromagnetic spectrum, from radio waves to gamma rays. When these beams sweep past Earth, we detect regular pulses of radiation, hence the name pulsar. But what makes the Crab pulsar truly special is its role as the nebula's powerhouse. This rapidly spinning dynamo generates an enormous amount of energy, creating a powerful wind of particles and electromagnetic radiation. This pulsar wind energizes the surrounding nebula, causing it to glow with an eerie blue-white light. It's like having a cosmic generator at the heart of a vast celestial light show. The precision of its rotation is remarkable. Despite spinning 30 times each second, it keeps nearly perfect time, slowing down by only about 1 millisecond per century. This incredible precision makes it one of the most reliable natural clocks in the universe, so much so that astronomers have used it to study everything from general relativity to the nature of space-time itself. Speaking of cosmic wonders, I hope you're enjoying this journey through one of the universe's most fascinating objects. If you're as amazed as I am by this celestial masterpiece, take a moment to hit that like button. It helps spread these cosmic wonders to more curious minds across our pale blue dot. And here's something I'd love to hear from you. If you had the chance to name your own nebula, what would you call it and why? Would you name it after its appearance, like our crab-shaped friend here? Or perhaps after a mythological story that inspires you? Share your creative cosmic names in the comments below. Remember, every great discovery in astronomy started with human curiosity and imagination, just like yours. Who knows? Maybe someday, one of you watching this video will be naming real celestial objects. While the Crab Nebula's visual beauty captivates our imagination, its true value to science extends far beyond its aesthetic appeal. This cosmic laboratory, situated 6,500 light-years from Earth, serves as a natural experiment that has revolutionized our understanding of fundamental physics and astronomy. Let's explore the 4 major ways this celestial wonder continues to advance our scientific knowledge. First, the Crab Nebula provides an unparalleled window into stellar evolution. By studying this supernova remnant, we've gained crucial insights into how massive stars live and die. Since we know exactly when the original explosion occurred, we can track how the nebula has evolved over nearly 1,000 years. This timeline allows us to verify and refine our models of stellar evolution, helping us understand the fate that awaits other massive stars in our galaxy. Think of it as watching a cosmic time-lapse in real time. Every observation adds another frame to our understanding of how supernovae transform into nebulae, and how these spectacular explosions contribute to the cosmic cycle of stellar birth and death. Second, the nebula serves as an extreme physics laboratory that we could never replicate on Earth. The plasma conditions within the nebula, with temperatures reaching millions of degrees and powerful magnetic fields, allow us to study matter under conditions far beyond our technological capabilities. These observations help verify theoretical predictions and sometimes reveal entirely new phenomena that challenge our understanding of physics. The third crucial lesson from the Crab Nebula involves the origin of heavy elements in our universe. Through spectroscopic analysis of its filaments, we can directly observe the products of stellar nucleosynthesis, the process by which stars create heavy elements. The nebula contains significant quantities of elements like iron, nickel, and various rare earth metals, providing direct evidence of how these crucial elements are forged in stellar explosions and distributed throughout space. This process has profound implications for our own existence. The calcium in our bones, the iron in our blood, and the gold in our jewelry were all created in supernova explosions similar to the one that created the Crab Nebula. We are quite literally made of stardust. Fourth, and perhaps most extraordinarily, the Crab Nebula acts as nature's own particle accelerator. The pulsar at its heart accelerates particles to energies far exceeding what we can achieve with our most powerful machines on Earth. These particles, traveling at nearly the speed of light, interact with the nebula's magnetic fields to produce radiation across the electromagnetic spectrum. This natural particle acceleration laboratory helps us understand fundamental aspects of high-energy physics. The processes we observe in the Crab Nebula have direct applications in developing better particle accelerators and understanding cosmic rays that bombard Earth from space. Beyond these four main areas, the nebula continues to surprise us with new discoveries. Its regular pulsar serves as an ultra-precise cosmic clock, helping us test theories of general relativity. The nebula's interaction with its environment provides insights into the dynamics of interstellar space. Even its gamma-ray flares, discovered relatively recently, challenge our understanding of particle acceleration mechanisms. The Crab Nebula's significance extends far beyond its mesmerizing appearance. Let's explore this celestial wonder through the eyes of leading experts who have dedicated their lives to unraveling its mysteries. Dr. Jocelyn Bell Burnell, the renowned astrophysicist who co-discovered pulsars, shares a fascinating perspective on this cosmic treasure. Having spent decades studying neutron stars and their remnants, she emphasizes how the Crab Nebula serves as an unprecedented natural laboratory. In her words, the Crab Nebula stands as one of astronomy's most precious gems. Its rapidly expanding shell and central pulsar provide us with unique insights into the physics of supernovae and neutron stars. It's essentially a time machine, allowing us to witness cosmic events that typically unfold over millions of years. Dr. Stephen Reynolds, a leading expert in supernova remnants, builds on this insight. What makes the Crab Nebula truly exceptional is its youth. At less than 1,000 years old, it's practically a baby in astronomical terms. This relative youth means we can observe processes that are usually hidden in older remnants. The nebula's unique characteristics have drawn attention from researchers across multiple disciplines. Dr. Victoria Caspi, an authority on pulsars and neutron stars, points out, the Crab pulsar is like the perfect cosmic laboratory. Its precise rotational period and powerful magnetic fields allow us to test fundamental physics theories in ways impossible to replicate on Earth. Astronomers particularly value the nebula's role in calibrating our understanding of cosmic distances. As Dr. Robert Kirshner explains, the Crab Nebula serves as a standard candle for high-energy astronomy. Its consistent emission across multiple wavelengths helps us calibrate our instruments and verify our observations of more distant objects. Perhaps most intriguingly, the nebula continues to surprise even seasoned researchers. Dr. Roger Blandford, a theoretical astrophysicist, notes, just when we think we understand the Crab Nebula completely, it shows us something new. The gamma-ray flares we've observed in recent years challenge our existing models and push us to develop new theories about particle acceleration in extreme environments. These expert insights highlight why the Crab Nebula remains at the forefront of astronomical research. It's not just a relic of a stellar explosion, but a dynamic laboratory that continues to shape our understanding of the universe's most extreme phenomena. The nebula's ongoing study represents a remarkable collaboration across the global scientific community, combining observations from ground-based telescopes, space observatories, and theoretical modeling to piece together its complex story. Let's explore some truly mind-bending facts about the Crab Nebula that showcase just how extraordinary this cosmic wonder really is. Imagine standing outside on a moonless night, trying to read a newspaper. Impossible, right? Not if the Crab Nebula's supernova happened today. The explosion was so bright that for several weeks in 1054, people could read at midnight just from its light alone. The supernova shone with the brightness of 400 million suns, visible even in broad daylight for 23 days straight. Speaking of impressive numbers, the nebula is currently expanding at a staggering speed of 1,500 kilometers per second. To put that in perspective, at this speed, you could travel from Earth to the Moon in just 4 minutes. This cosmic debris cloud continues its expansion even today, nearly a millennium after the initial explosion. The Crab Nebula's central pulsar is an overachiever in its own right. This cosmic lighthouse spins an astounding 30 times every second, faster than a helicopter's rotor blade. Despite being only the size of a small city, it generates enough energy to power the entire nebula with the equivalent brightness of 100,000 suns. Here's something that would make any physicist's jaw drop. The magnetic field around the pulsar is so intense that it's about 100 million times stronger than the strongest magnetic field we can create on Earth. If you brought a regular refrigerator magnet within 1,000 kilometers of the pulsar, it would be torn from your hand with enough force to kill you. The nebula serves as a natural particle accelerator that would make any laboratory physicist envious. It accelerates particles to energies far beyond what our most powerful particle accelerators can achieve. Some particles within the nebula reach energies thousands of times higher than those produced by the Large Hadron Collider. Perhaps one of the most fascinating aspects is how the nebula appears different depending on how you look at it. View it in visible light, and you'll see the beautiful filaments that gave it its crab-like appearance. Switch to X-rays, and you'll witness a pulsing beacon of high-energy radiation. In gamma rays, it becomes one of the brightest persistent sources in our sky. The nebula's influence extends far beyond astronomy. It's become a crucial calibration tool for high-energy telescopes, acting like a cosmic standard candle. Scientists often point new telescopes at the Crab Nebula first to ensure their instruments are working correctly, earning it the nickname, the standard candle of high-energy astronomy. Here's a thought-provoking detail. Every chemical element heavier than iron in your body was created in supernova explosions like the one that formed the Crab Nebula. The gold in your jewelry, the silver in your electronics, and many other heavy elements were forged in these cosmic furnaces. Despite its violent birth, the nebula is creating new possibilities. Within its expanding shell, astronomers have detected complex molecules forming, including water and even some organic compounds. It's a cosmic reminder that even in destruction, the universe creates the building blocks for new beginnings. As we look toward the horizon of astronomical research, the Crab Nebula continues to present both fascinating challenges and promising opportunities for future discoveries. Let's explore the frontiers of our understanding and peek into what the future might hold. Current research faces several intriguing challenges. Despite decades of study, the exact mechanism behind supernova explosions remains partially understood. Dr. Adam Burrows, a leading theoretical astrophysicist, notes, "We can simulate these explosions with supercomputers, but nature still holds some secrets." The precise way in which the shock wave is energized and propagates through the dying star continues to challenge our best models. Another significant puzzle lies in the nebula's energy budget. The pulsar at its heart pumps out more energy than our calculations predict it should. This energy disconnect suggests there might be fundamental physics principles we haven't yet grasped. Understanding this energy mystery could revolutionize our knowledge of extreme physics. The nebula's magnetic field structure presents another compelling challenge. While we can observe its effects, mapping its precise configuration remains difficult. This complex magnetic architecture plays a crucial role in particle acceleration and energy distribution throughout the nebula, making it a critical piece of the puzzle. Looking to the future, we stand at the threshold of exciting new possibilities. The James Webb Space Telescope is providing unprecedented views of the nebula's structure and composition. Its infrared capabilities allow us to peer through the dust clouds, revealing previously hidden details about the nebula's chemical makeup and evolution. The upcoming Vera C. Rubin Observatory promises to transform our understanding of the nebula's dynamics. Its ability to survey the entire visible sky every few nights will help us track subtle changes in the nebula's structure, potentially revealing new phenomena we've never observed before. Advanced particle physics facilities being planned or constructed worldwide will help us better understand the extreme conditions within the nebula. By replicating similar particle acceleration processes on Earth, we can test theories about how the nebula energizes its surroundings. Quantum computing developments offer hope for creating more sophisticated models of supernova explosions. These complex simulations could finally bridge the gap between our theoretical understanding and actual observations, potentially solving the long-standing mystery of the explosion mechanism. Perhaps most excitingly, the nebula continues to evolve before our eyes. Each year of observation adds to our understanding of how supernova remnants develop over time. This ongoing natural experiment provides an unprecedented opportunity to test and refine our theories about stellar evolution and death. Machine learning and artificial intelligence are revolutionizing how we analyze the vast amounts of data collected from the nebula. These tools help identify subtle patterns and relationships that human observers might miss, potentially leading to breakthrough discoveries. The future also holds promise for understanding the role of objects like the Crab Nebula in galactic evolution. As we discover more about how these remnants interact with their surroundings, we're building a clearer picture of how they influence the chemical and physical evolution of galaxies. International collaboration continues to grow, with observatories worldwide coordinating their efforts to study the nebula across all wavelengths simultaneously. This global approach provides a more complete picture than ever before possible. As we conclude our cosmic journey through the remarkable story of the Crab Nebula, let's take a moment to reflect on what we've discovered together. This celestial wonder is far more than just a beautiful sight in our night sky. It's a cosmic chronicle, telling an epic tale of stellar life and death. From its explosive birth in 1054, witnessed by astronomers across the ancient world, to its continuing evolution that we study today, the Crab Nebula stands as one of astronomy's most valuable treasures. Through its glowing filaments and pulsing heart, we've learned fundamental truths about our universe. We've seen how stars live and die, how the elements essential for life are forged in stellar furnaces, and witnessed nature's most powerful processes at work. This celestial phenomenon reminds us that even in death, stars can create something of extraordinary beauty and scientific importance. The Crab Nebula serves as our cosmic teacher, showing us that the universe is not just a collection of distant lights, but a dynamic theater where matter and energy dance in ways that continue to challenge our understanding. From its central pulsar to its expanding shell of gas and dust, every aspect of this nebula contributes to our growing knowledge of the cosmos. Now, let me share something personal with you. Every time I study objects like the Crab Nebula, I'm reminded of how interconnected we all are with the cosmos. The very atoms in our bodies were once part of stars that exploded, just like the one that created this beautiful nebula. We are, in the truest sense, children of the stars. If this cosmic journey has sparked your curiosity about the wonders of the universe, I invite you to join our growing community of space enthusiasts. Hit that subscribe button and activate the notification bell to become part of our Exploring the Universe family. Together, we'll continue to unravel the mysteries of the cosmos, one celestial object at a time. Share this video with friends who gaze at the night sky with wonder, and let me know in the comments which aspect of the Crab Nebula fascinated you the most. Was it the incredible energy of its pulsar, the beautiful complexity of its structure, or perhaps the historical significance of its discovery? Don't forget to give this video a thumbs up if you've learned something new today. Your support helps us reach more curious minds across the globe and spread the wonder of astronomical discovery. Thank you for exploring the universe with me today. Clear skies, and I'll see you in our next cosmic adventure.